Hey there, welcome to the last video of 2024. I have a very interesting math puzzle. So what you have in front of you is a square, and I have colored the square in layers. So let's start with it. So this is the innermost layer, and then we have the dark gray layer, and after that the light gray layer. Okay, so if you think of the dark gray layer as the first one and the light gray as the second one, you realize that the first layer has 8 squares in it and the second layer has 16 squares in it. The question for you is, what about the 100th layer or the 100th circle around this center? So if you imagine a square that's so large that you have a 100th layer or the 100th circle, and you need to find out how many squares are there, will be there in that 100th square, the 100th circle. So pause the video here, take your time, think through that, go through your productive struggle, and then come back to see how we can solve this problem. All right, welcome back, and I hope you were able to do all of what I asked you to do. And here's how we would approach this problem. So first, let's think about the nomenclature. The very innermost square I would call as level 0. Then I have circle 1, circle 2. So in other words, one dimension is the count of the circles. So I have circle 0, I have circle 1, I have circle 2, I have circle 3. The second one is the count of the squares. So circle 0 has 1 square. Circle 1 has 8 squares, circle 2 has 16 squares, so on and so forth. But we need more than this. So one other thing that you can notice is the length of each square. So for example, the length of level 0, circle 0, is 1. It's a 1 by 1 square. The length of level 1 is a 3 by 3 square. The length of level 2, which is one dimension of that square, is a 5 by 5 square. So you already see the pattern. So the third one would have 7. The third one would have 7. The fourth one would have 9. So you see the pattern here. So now the question is, if I keep going in this direction, what about the 100th square? The 100th square, there should be a formula connecting it. So you can, in fact, think about it as 100, or you can think about it in the abstract n. So if I have to go to the nth circle, how many, what would be the length of that nth square? All right, so let's think about that. If you see this, you realize that the difference between them is always 2. So that's a clue for you that there has to be a multiplication factor of 2n. So 4 times 2 is 8, 3 times 2 is 6. That doesn't lead you to the size. So you add 1 to it and you'll be able to connect it out. So 4 times 2 is 8, 8 plus 1 is 9, 3 times 2 is 6, 6 plus 1 is 7. So by that connection, if you take the nth circle, then the size of that nth circle is going to be 2n plus 1. Which means for the 100th circle, it would basically be 201. But this still doesn't solve my problem, right? So how do I get to this particular thing? How do I get to this 8? Now you've got to do a bit of observation. So if you think about the first circle, it's a 3 by 3 square, and you're removing the inner square out of it. So it's a 3 by 3 square, which means there are 9 in total, and you're subtracting the 1 there. Okay, so I see some pattern there. Let's go to the next one. The next one is a 5 by 5 square, which is 25. And you're subtracting the inner square, which is a 3 by 3. So in other words, this 16 is nothing but the 5 square minus 3 square, which is nothing but 25 minus 9, which is 16. Let's see if the same thing applies here. So this would be 3 square minus 1 square, which would be 9 minus 1, which would be So by that calculation, the next one should be 7 square minus 5 square, which is 49 minus 25, which is going to be 24. Okay, so you can see the pattern here as well. So you almost have this to be 8, 16, 24. So what would it be for n? Right? And you can almost see that there's already a pattern which is nothing but 8 times this. So let's test it out for the next one. What is 9 squared? It's 81 minus 7 squared, which is 49. And this is nothing but 32. So 100 times 8, 800 should be the answer, which is also nothing but 201 square minus 199 square, which you can apply. You can multiply this, or the better way to do this is to basically say the difference, a minus b, is going to be 2, and a plus b is going to be 400, giving you 800. The answer in terms of n would basically be 8n. And that's because you can derive the same thing using algebra as well. 2n plus 1 whole square minus 2n minus 1 whole square, which is the previous number, is going to be a difference of 2 times. When I add both of them, I'm going to get 4n. In other words, it's 8n. So the 100th one would be 800 squares, and the nth one would be 8n squares. So that's how you derive this, solve it, and it's solved for any possible thing. Now let's extend this slightly different. So imagine a chessboard where the number of squares is even, and the center in this case is not 1 but rather 4. So this is my level 0, which has 4, my level 2, which is going to be a 4 by 4, which is 16. 16 minus 4 is 12. That's my level 1. And then I have my level 2, which is 36 minus 16, which is 20. So level 0 is 4 squares, level 1 is 12 squares, level 2 is, as I said, 36 minus 16, which is 20. So here too, you see the same 8 squares being added each time. In this case, what do you think is going to be the answer for the 100th circle? Or what's it going to be for the generic n? If you can solve this, please share your answer in the comment section, and I will see you in the brand new year of 2025 in the next video. Thank you so much.